So a round of applause as it comes up, please. Thank you. Thank you.
Thank you, ma'am. I also want to stand on existing protocols where giving a special permission to the representative of the Vice Chancellor and the team leader. Drones. What are drones? Basically, they are manned area vehicles. Unmanned is the case that you don't need human being to actually be inside for it to be deployed up into the sky. But it's not as if there is no human intervention there. You have a case where it is either it can be autonomous or can be operated by a human in terms of the flight controller. You can have a flight controller system that's being operated by humans. Various sizes, shapes, and dimensions. And one of the few things that we need to know in the deployment of what we call drones or manned area vehicles in agriculture is actually what we call the payload. But we'll still talk about it. Most drones are made up of electric motors, rotors, microcontrollers, flight controllers. Those are this. And part of it, but also we what we call the GPS, to be able to determine where and where the system is going. Sensors are integrated into it, actuators to determine, to be able to give us what we call a design parameter from sensing to microcontroller, and then we have an actuator. Because if you are able to sense, you should be able to deploy what you have sensed out. Next slide. Roles of drones in agriculture. We can apply drones in so many areas. One of it is to monitor the soil parameter. You can use it to monitor the nutrients in the soil. We have what we call the NPK sensors. NPK, potassium, calcium, nitrogen, thank you, sensor to achieve it. Yes, to spray fertilizer, pesticide, herbicide, equipped with cameras, and then you can also use it to actually detect plant diseases. Let me say this. To detect plant diseases, yes, there is a second role there where we have a trained AI model. You can train AI model, incorporate it into your microcontroller, deploy your drone over the farm, and it's going to give you whether there is an outbreak of disease. We've done it for maize and cassava in the mechatronics lab. So you can use it to actually detect plant disease, track the health of the plants, and then this is just an example of the drone. Like I said, you can see the carriage, you can see the drone trying to apply what we call liquid fertilizer. This is the traditional way of doing it, and then this is the modern way of doing it. Types of drone. I don't want to, maybe this is a bit theoretical. Just types, different types of drones. There's drones that can go, yes, thank you. If you look at the first one there, you have the hybrid drones. This is very good. There is precision, and then you can actually go far. There is the fixed wing that can actually be used to go far. You spray fertilizer, spray pesticide on the farm, and then the multi-rotor, which is quite common and relatively very cheap. We have that too that can actually be used to deploy a lot of it. And let me say this because of time, it's not only about spraying fertilizer, doing irrigation that you can use your drone to do. You can actually use drone in the planting of what we call vegetables. The traditional way of planting vegetable, sometimes you spray the broadcast the seed and then you have it. Because this particular drone is actually meant to do that. And to actually help in broadcasting that seed of vegetable, we fly it at a very low altitude, not high now, very low, and then we can have a case of being spraying the seeds or the vegetable there. Drone mapping. Drone mapping is the use of what we call UAV to capture high quality image and data, creating accurate 3D representation of the area. When I say 3D, with three-dimensional representation of the area. This will enable us to determine the area suitable for a particular plant, maybe another area that is we need to actually carry out what we call irrigation. It gives us a good survey or survey of the land, better than maybe what we can get from satellite or maybe ground survey. So we have that. So that's what, and in agricultural mapping, involve gathering, analysis, visualization of what we call strategic data about crops, soil, vegetation, and use. So basically what we do in using drone for agricultural mapping is to get data from the ground and then use that data to determine what is going to happen to either the plant that is harmed, that this will lead to a better efficiency, give us a food security, and then we can also determine to say, okay, this is the area we can irrigate, this is where there's an outbreak of diseases, and this is where we need to work on. These are the types of agricultural mapping, the crop type mapping, the land use, the soil mapping, the yield mapping, the field condition mapping, and then the topographic mapping. Basically, when we talk about this mapping, it's not as if the drone can just do it on its own. We also need softwares for the drone to be able to do what we're asking the drone to do. Because, and then we need to incorporate this software into our microcontrollers. And then, the microcontroller is just like the brain of the system. And then we have a system that will then give us what we call an application system that will activate and give us a decision-making system concerning what we have asked the system to actually do. So we have that. That is the type of agricultural mapping that we have. Next slide. In order to achieve this, there are a sequence of activities that we need to do. The first thing is we need to plan and prepare for what we want to do. We also need to get what we call data acquisition, mapping process, and then analyzing what we have. Like we know, if we want to deploy a drone, we actually need to know, okay, what is the size of the farm? What is the structure of the farm? Yes, normally it's going to be maybe rectangular in nature, but you can also have a situation where we have the size of the farm in a rectangular form. And then we must be able to, okay, acquire those data, give the system the data, and then be able to deploy it. Like if you are using drone for irrigation through what we call the thermal sensor, you need to first deploy the drone. The drone will test, using those sensors, will test the humidity of the soil and then send that back to you. Then you can then use that same data to redeploy the drone for irrigation. So there is a data acquisition point in the deployment of the drone. There is also the area mapping, telling us this is what I've seen. And it's not only in irrigation, even in determining the nutrients of the soil and even the erosion, the effect of erosion on a particular farmland, we can actually use our drone mapping to do that. And our software, time will not permit me to start mentioning the software. There's software that we can use to do that. These are some of the sensors that we use. There are so many for all of these. The RGB sensor, the thermal sensor, I've talked about it. The LiDAR sensor. LiDAR is a light-dependent range sensor. It's a very good sensor, and actually it's not that expensive. And you can actually use it to do a lot of mapping work on the farm. And we have that. Challenges. We cannot run away from the fact that this is a new technology, and then there is this initial cost that always scares farmers away from using drones. Technical expertise, there's also what we call regulatory restrictions, and then it's weather dependency, because if there is a lot of winds or rain, you might not be able to actually use your drone, so that the drone will not be missing in action. Solution. Well, one of the solutions that I would say outside this is, yes, there could be collaboration between farmers. And we have seen this happening in so many other countries, especially in India. Farmers will collaborate to actually get a drone, and then maybe they use it in a particular farm today, and tomorrow they can actually take it to another farm to use. So we have that collaboration. Outside all of this, yes, government can intervene. Yes, we know as governments, we cannot totally depend on them, but I believe that farmers can come together and get, like I said, yes, it's relatively, it's not that expensive. We can actually, it's something that, yes, and not average now. Above average farmer can get. Yes, a small one, maybe around 1 million. But at the end of the day, it's the end will actually justify the means. So we can always do that. Farmers can put resources together to share the drone and then the software that is involved. Yes, these are some of the places that they have used drone mapping and the results that they've been able to get. We can see for India, for California, for Kenya too. It's not common, but visual agriculture has been used in Nigeria, not basically about drone. I think I need to go to soil. Let me just talk about soil monitoring. I will not use the slides. Yes, you can monitor soil through the process of precision agriculture. And yeah, so let's just use an example. Irrigation again, smart irrigation. We have what we call DHT, the digital humidity and temperature sensor. This is what we actually use for what we call smart irrigation. And it's straightforward. Once you put your DHT inside the soil, it checks the humidity of that soil. And it's checking the humidity of the soil. Once that humidity falls below the range for that particular plant, it's going to send a signal to your microcontroller. And the microcontroller will just activate your pump, the valves of your pump, and then the EU of irrigation will start. So you can actually use your DHT to monitor the moisture, the soil science